we're pretty excited about this guy. Okay, so we've had, so we've been very lucky to have him present at the summit before in Montreal. Joined us at the summit as one of our presenters, talking about making bespoke tech for your loved ones. And despite the fact that we are from a place where you would say Guy Dupont, the reality is he's from a place where you would say Guy Dupont, which is apparently a way you can pronounce that name. But we're super stoked to have him on today. We're going to say, welcome, Guy Dupont. Thank you for joining us this morning.
Hello, good morning. It's, when you really draw out the Dupont, like I can feel the pain. Like I know it's wrong somewhere deep in my body.
Yeah, I mean, it's just like you're almost doing it right.
Well, don't blame me, blame my grandparents, I guess. We even have the lowercase p. Like someone modified that. Like someone moving in, they were like, no, bring that p down. We don't need.
Yeah, they're like, let's make it small. Very interesting choice. What are you working on these days, guys?
What am I working on? All right, this is I'm gonna need help from you and this lovely community. I'm gonna do something I don't usually do, which is I'm gonna show a bunch of in progress stuff. I know we're all supposed to like build in public and whatnot, but like I don't know. Part of the fun for me is the kind of reveal, and I'm gonna talk about some in progress stuff because I need help getting it over the finish line. So either you can just tell me not to finish it or tell me to keep going. So
okay, we'll give you our honest opinion.
Yeah, we're officially the chopping. We'll let you know
if it's not good. Don't finish it.
And then I'll tell you before each one if I actually want you to say that, because in some cases I don't mean that. Okay, so actually, the first thing I'm going to show is something I finished recently that I'm really proud of, and I'm going to share my screen here. Share screen. We're going to do this. Cool. Can you see what I'm seeing, or can you put it in the?
Got it.
Hi, Andrew. Okay, so I did this thing recently. I live in an apartment building where there's like 16 units in this building. It's an old building, and so there's probably on the order of like 25 people, and we share 2 washing machines and 2 dryers, and they're very nice, but like that's not quite enough.
No.
especially now like there are multiple families in here with small children, which are basically just laundry producers. And so I got so sick and tired of walking all the way down to the basement just to find out that everything was already in use. So I rigged up a way to basically sense if the machines are running at any given moment. And I made this cute little website. I'll show the website after because I have to like switch tabs. But basically, anyone can scan a QR code down there, go to a website, and see the state of the laundry machines. And so what that ends up looking like. This was the first version. If I can make it bigger, if I knew how to use a computer here.
That was never an expectation of this live stream. Don't you worry.
Okay.
No one can.
Here's all my metadata. I'm open sourcing my my life. You can see what I used to take the picture. Anyway, this was the first prototype. So basically, it's a NRF 52840, whatever the most common Nordic chip is for Bluetooth stuff. A battery and some magnets. These magnets did not work, but I'll show you the later revision. But basically, this thing just sticks right to the laundry machine. It's like non-invasive. It just like literally hangs onto the laundry machine. And that little dev board, the Xiao, has a little microphone built in. And so what it does is it just records a very small snippet of like the laundry machine. It's literally pressed up against it. It records for like half a second, and then it beams that audio recording over to this particle. This is a particle tachyon, which I'm obligated to say they sent me, which shout out particle. Thank you. But so the particle is connected to the internet. It's got a cellular connection, and so the particle takes that audio file, runs it through a little classifier, and determines like, oh, is that machine running or not, and then it pushes the kind of verdict, the classification up to my little website. And so the cool thing about this is it's like not infinitely, but it's scalable. So I can make one of these little modules per laundry machine, and each one costs me about $15 total. And I wrote the software in a way. This is what the final one looks like. You can see I switched dev boards, I switched microphones. I'm using an Adafruit microphone, and yeah, so I can put I have 4 of them down there, and all I have to do to spin up another one is literally just flash the firmware, and the particle tachyon software will detect them automatically as they come online. And so, not that I think like I worked really hard to make it extensible like that, but I realized I was like, nobody's adding laundry machines. Nobody's gonna do it. Like it's a little optimistic. So I think it's more for like if I need to
machines.
Yeah, maybe you come down there one day and you're like, wow, 5 new laundry machines. That's crazy.
Yeah, no, I think the spin there is it'll be easy to replace them if they break, but then it's like, well, they're not going to break because I designed them so well. I'm just kidding. They very well might break, but they have been running down there for I think I'm on like 2 or 3 weeks with only a couple. I had to like restart the. Thanks, Liz. This is another project. The phone I'm using I'm QA testing this phone for another project right now. But yeah, so so I can replace these easily. The battery lasts forever because those NRF chips are crazy power efficient. So it draws less on average. It draws like less than a milliamp. And with that beefy battery, it's like I'm hoping it'll last me like months and months. The only expensive part is when I actually have to like beam the audio to the tachyon, but it's still not too bad. So that's one thing I built that I'm really proud of. I don't usually build things that are super practical. I think you know my work. It's usually they tend to be the thing I say about my work is it's like art projects deeply disguised as real products. And so I'm usually building one of something. I'm usually posted online. And it's about the conversation more than the actual thing. But it was really nice to actually build something. Thanks, Chippy. To build something that's like useful. I know that's like a duh, but it's not something I usually do. And flexing the muscle and working the muscle of thinking about designing things to actually last. Even when you're building small quantities is like really fun. And so this was a great project for that. What else am I working on? I've got my stuff over here. Okay. So this one is very early, but I'm very excited about it. So do you all in Canada have little free libraries?
Oh yeah.
We sure do.
We sure do.
People love a little free library. It's little, it's free, it's a library. I do think that some people need to know that all libraries are free, not just
even the big ones. Yeah.
Big libraries also.
What are you talking about?
Still good.
Libraries are free
this whole time.
It's crazy. It's crazy.
I'm just kidding. Libraries are free. Everyone go to your local library. Your local library probably has 3D printers now.
That's true.
Generally speaking, like that's has just been a thing apparently. Anyway, so little free libraries, for folks who don't know, they're basically people build these tiny little like dollhouse sized things and put them in their front yard and fill them with books, or rely on other people in the community to fill them with books. And you can kind of leave one, take one. And it's just like a cool little, neighborhood thing. So I've been thinking a lot about community in, just keeping things local, keeping things kind of less online, and what that means in the past year and the coming years. And so I'm working on a design for a little free e-library.
Oh.
And so the idea is this will have its own little Wi-Fi network, and it will host a number of digital files, which will all be legally obtained and be shareable. But the only way you'll be able to get the documents off of this is by going up to it, connecting to its network, and there's a little web portal that will show up on your phone, and you can save it to your local device. And so I like this idea that it's digital, but it's not online. You still have to physically be there to get it. And yeah, I'm really excited about this. I think it could be cool, even for stuff like not just books, but like flyers for your local stuff, your Parks and Rec department, or voting information, stuff like that. Like, because it's digital, it's easier to keep up to date, and things can be kind of infinitely distributed. But again, it's specifically designed and only accessible for people kind of near you. So I should mention, this is the enclosure. I'm working with my friend Adam Zaloof, who he's very active in the community as well. He's he occasionally writes for Hackaday, does awesome work. Turns out we live very close to each other. We've become close friends, and he is helping me with this. He's a CAD master, and so this enclosure, which like the door actually more like I'm not on this level of 3D printing yet.
What a beautiful functioning door.
Yeah.
It's a functioning door. There's going to be like a switch that turns on a little lamp. We're going to have a little sconce.
God, yes.
Okay, in case we do still need to tell you, yes, keep going.
You have our approval. You can continue
keep
this
working
project.
on this project.
All right. Cool. Good. All right. I got 10 minutes. That one, that I'm excited about. I'm excited about finishing that. All right, so this last one's a little ridiculous. There's quite a bit of backstory. I ran a marathon this year. Actually, I ran a marathon. Beautiful functioning door. I ran a marathon like 3 days before I saw you all at the summit. Like the flight over there was so uncomfortable.
I feel like
I had just run like more than anyone ever should. It turns out making your body do ridiculous things is cheaper than therapy here. So I ran a marathon, and part of my like early training, this would have been about a year ago, I started training for it, was I wanted a project to associate with the marathon to kind of keep me motivated to train. So it was going to be something related to me running, or a race, or whatever. I just I knew in order to keep myself motivated, I wanted this kind of other thing attached to it. And so pretty early on, I decided, taking the pun of "does it run Doom," I decided to ask myself, can I literally run Doom?
Of course.
A question we've all asked.
And so the challenge for myself became, can I power, as in provide electricity for a full playthrough of the original Doom game using only energy harvested from my body?
Right. Yes.
And so it became a long kind of journey, and I'm going to share a different tab now. How do I stop this? Stop screen. Sorry, I'm going to do that again. And share Doom. There we go. So it was a lot of hardware iterations. I started with the RP2350, and this was my first just getting Doom running on a microcontroller, which people have done obviously a million times, the whole thing. But I had some very specific power constraints, or whatever, so I needed to start from scratch. So this is just showing I got it running, and you can just see it's logging it's running a demo, and the Doom guy is firing the weapon, and things are dying. And I switched to, this is a Nordic chip again. And this is the most boring video I've ever filmed. I don't know why this is in here, but so basically I switched to Nordic chip because I needed lower power. And then this is when I first got the screen up and running. So this is one of those, the memory displays. This is an Adafruit breakout. And if it loads, please load. I mean, you can kind of tell what's going to happen. So yeah, that I promise that actually plays the game. This is I had to work for a while without a screen. Let me refresh this, see if it works. Yeah, there we go. Yeah, there we go. And so this is actually the game rendering over serial, like in a terminal. You can kind of tell what's happening, but basically I had to strip out all of the assets in order to fit. Like to meet my power constraints, I had to use a chip which didn't have as much memory, and sort of fit the game in memory out. You can see the weapons in there is just a black square, and all the enemies are just stick figures like this. Okay, so this is this is now running like full speed on a small screen, and you can see I got it down to pause it there. That is less than a milliamps. It's 757 microamps. So the game is actually running like full on that power draw, which is as far as I know, and I've googled a little bit. As far as I know, this is the lowest power Doom, I'm going to call it console, that's ever been done. I'm like 90% sure. And we can kill the screen sharing if you don't mind. Thank you. What ended up happening was my friend Kevin, who you all know. Is Kevin coming on later? Jumperless Kevin Capuccio? He was on.
I don't think.
Not this
year. No.
All right. Kevin saw me working on this project and was like, well, I'm not going to not help with that. And so he designed me this board, which is my favorite PCB in existence. Doom Guy, and I scratched this one. Sorry, Kevin. Doom Guy with running shoes on. And this is actually the entire console. So this has a power harvesting chip here. It's got the microcontroller, which is an Ambic Apollo. I forget the exact number. Which is again crazy low power. And Kevin put a D-pad on here, so you can actually play. Like if you hook up the screen, you can actually like play the game. But because I'm running, like I'll be, physically moving. I'm going to be running a pre-recorded demo while this happens. And so so this board uses virtually no power. It's slightly more than what I just showed you. I think this ends up being like between 1 and 2 milliamps, but still like well within. I can power that with my body range. And the way I'm doing that, originally I was going to do like thermal harvesting. I bought a bunch of those like Peltier modules and like glued them to my body thinking that would work. But then enough people said to me, is like, no, there's got to be some like mechanical way to do this that's easier. And so I designed this. This is my harness. This is my Doom harness. And it's this string. This string is attached to an old running shoe that I drilled a hole in. It's like kind of permanently in there. And then this is a 3D printer stepper motor, like a NEMA 14 motor. And this is the pull start thing from a weed whacker. I was walking down the street and I saw someone cut it like using a weed whacker, doing lawn care, and I was like, that's what I need. And so when you pull this, runs through this PCB, which rectifies the output of the stepper motor and turns it into a source of electricity that can be used to power this board. And do I have a video of me actually looking like an idiot using it? No, I don't. So that'll be to come. That'll be what if you all decide that I should keep doing this and I should actually do a run and power Doom. Only if that's the verdict, that's what will happen, and eventually make it onto my YouTube channel. If I don't trip, which I almost certainly will trip because I am attaching a rope to my foot.
Once again, we're saying yes.
Yes.
Yes. Project approved.
You may continue development on this project.
Apparently I can make this little thumbs up happen.
Oh yeah. Oh,
just children.
PSA. Let's do a PSA on that. I'm so glad that
PSA
happened.
to the people.
If you have an Apple machine, and I have one too, and it's relatively new, they automatically turn on those like emote things.
Oh.
And if you go up into your like that little thing that highlights in your toolbar, like the top bar that shows your camera's running, you can turn them off there, but they're automatically on. So if you're in an important meeting, and certain gestures will make like balloons happen and stuff. So PSA.
My important meeting.
Yes. Luckily, I've never been in an important meeting, so it's fine. But I will be turning it off later.
Good. Yeah. That's what I got. I'm glad the phone worked too. So this is part of a commission project I can't quite talk about. But yeah, so it turns out if you just plug an old handset into a cheap, I'm not gonna be able to show it on. Oh, no. Anyway, if you plug an old phone handset directly into like a cheap USB audio card, it turns out it actually sounds pretty good. Just like literally the wires from the microphone into the microphone jack and the speaker into the headphone jack. It works well.
Cool. Love it. Honestly, Guy, you're always doing such fun, wonderful, and as Chipper said, whimsical things. It's just such a fun time to keep up with your work. So hopefully if anyone wasn't familiar with your work yet, they'll be following along now because it's such a joy.
It's like constant, like cool, whimsical, well-designed hardware. Really like high recommend for following Guy.
It's true. It seems so natural too. He's just like this.
Yeah.
Yeah. You can't.
For years now, it's crazy.
Turns out you can't fix it. But thank you. No, I really appreciate that. And I should mention all of this, except probably this phone thing. All of this is going to be open.
Amazing.
It's going to be available. Yeah.
Amazing. Thank you so much for coming on today, Guy. It's always so fun. And as a fun other note, if you aren't aware, Guy's feet are open source. So if you've needed feet for anything, you can go use those.
True. There are models of my feet on my GitHub page, which is Dupont GU. So it's my last name.
We'll share it. We'll share it in a few minutes.
Okay.
Amazing. Thank you so much. It was so great to chat with you, and we will see you on the internet and maybe at the summit, hopefully.
Yeah, I have in another tab. I have Berlin flights. So hopefully.
We believe. Okay, talk to you soon, guys.
All right. Bye. Thanks, y'all.